So today we're going to look at the exponential functions. So let's have a look what questions were given. All right. So are the following functions increasing or decreasing? Good question. All right, so let's look at part A. So part A, our function is y equals, right? Y equals 2 to the power x. Well, if we draw this graph, what's the best way, I think, to really determine if something's increasing or decreasing is to draw it. We see that we get a function that looks like this, and it crosses the y-axis or intersects the y-axis at 1. So this is indeed an increasing function. All right, so let's look at part B. This one's interesting. So y equals -3 to the power x. All right, so again, let's draw this or sketch this. So if we just look at the function 3 to the power x, again, it looks something like this. Again, intersecting the y-axis at 1. And we have a horizontal asymptote given by the x-axis. But we have this negative sign in front of it. So this means it's being reflected in the x-axis. So our final function, perhaps we can use a different color. How about red? So our final, or our given function, y equals -3 to the power x, is actually this function here, this red one. Is this increasing or decreasing? It's decreasing. So this one's decreasing. And the first one, let's label the first one as increasing. And finally, part C, let's scroll over here. Let's go back to blue. Our function is y equals 1/2 raised to the power x. Again, let's sketch the graph of our function. An idea of what's going on. So when x equals 0, y equals 1. So when x is an increasing positive number, we're actually going to get a smaller value. Our y value is going to decrease. It's going to approach 0. And as our value for x becomes more negative, our function's actually going to get larger. So is this function increasing or decreasing? It's decreasing. All right, so I think I made a mistake. Yeah, no, we've got them all right. So A is increasing, B is decreasing, and C is decreasing as well. Good. So now let's go on to question number 2. Well, this is a big one. Given the function y equals 2 times 4 raised to the power x minus 1, find the following. Okay, so we've got a lot to do here. We need to find the parent function. So let's figure that out first, the parent function. So what do you think our parent function can be? So I think it's some kind of exponential function because we have this component right here, 4 raised to the power x. And if you notice, we're doing things to it. So we're transforming this part of the function, 4 to the power x. So this is a good candidate for our parent function. So our parent function is y equals 4 to the power x. On part B, they ask us what transformations are applied to the parent function. So we only have one parent function, so let's take that s away. Well, let's have a look. We're multiplying 2 by our parent function, so that is a vertical stretch by a factor of 2, and then we're subtracting -1 from it. So the -1 is a vertical translation down 1 unit. So let's write that in. Vertical stretch. Running out of room. A factor of 2 and vertical translation. Down 1 unit. All right. Let's look at part C. Horizontal asymptote. So horizontal asymptote. So we need to consider what happens as the x value gets large positively and very small negatively. So let's do this. So now let's do this off to the side here. So C. So let's look, we can consider limits. So let's take the limit of our function y as x approaches, let's start with positive infinity. Let's keep things consistent. As x approaches positive infinity, we're going to get a very big number. So this actually approaches infinity. Now, it doesn't look like it's a horizontal asymptote. We have one yet. So now let's consider as x approaches negative infinity. So again, we put our function y in here. All right, so now what's happening? So if we notice as x approaches negative infinity, 4 to the power x is going to get very small. So this first term is just going to be 0. The minus 1 is just a constant, so it's going to remain minus 1. So we end up with negative 1. So it looks like, therefore, y equals negative 1 is our horizontal asymptote. Is a horizontal asymptote. And it looks like I've not left enough room for this question. Okay, good. So now let's go back and see what else we were asked to find. We need to find the y-intercept in part D. So let's do part D on the left here. All right, so how do we find the y-intercept? Find the y-intercept by letting x equal 0. So let's do that. So part D, let's write our function at y equals 2 times 4 raised to the power x minus 1. We want to find our y-intercept, so let x equals 0. So y then equals, therefore, y equals 2 times 4 raised to the power 0 minus 1. Anything raised to the power 0 is 1. 2 times 1 is 2, so 2 minus 1. So therefore, our y-intercept is y equals 1. All right. And part E, the x-intercept. So how do we find the x-intercept? X-intercept, we let y equals 0 and we solve for x. So again, y equals 2 times 4 raised to the power x minus 1, let y equals 0. And let's see what happens here. Okay, let's solve for x. So we can bring the negative 1 over to the left-hand side. Divide both sides by 2, so we got 1/2 equals, again, I did not leave enough space for this question. 1/2 equals 4 raised to the power x. Okay. Let's see. Let's write 1/2 as 2 raised to the power negative 1. Now let's take logs of both sides. Or do we need to do that? Actually, we can rewrite 4 as 2 squared raised to the power x. So we have 2 to the negative 1 equals 2 raised to the power 2x. Our bases are the same, so therefore negative 1 equals 2x, or x equals negative 1/2. So this is our x-intercept. Is our x-intercept. Good. Okay, so now let's go back. So part F, we're asked for our domain. So let's look at our function. So it looks like you can put any value of x in there. There is no value of x for which this function is undefined. So our domain equals, instead of x such that x is a real number. Now our range, let's look at our range. So we have a horizontal asymptote. So when y equals -1, so that's the only value that y cannot equal. So it looks like our range is y can be any real number except y cannot equal -1 because it's a horizontal asymptote. So it never actually reaches that value. And finally, in part H, we're asked to graph. So we need to put all this together and see if we can graph the function. So let's find some space to draw the graph. This will be a challenge. Where should we find space for our graph? Do we have enough? Okay, let's go below, see if we can find some space. All right, okay, let's draw some axes in. Okay, so first things first, let's go back up. We have a horizontal asymptote of y equals -1. Let's draw that in. Let's say that's there. Let's put a dotted line, and y equals -1. Not bad. Okay, so next, let's put on all our key points. Our x-intercept is -1/2. Let's do that. Let's say that's right there. What's our y-intercept? Let's go back up and find our y-intercept. Y equals 1. Y equals 1. That's our y-intercept. Okay. Now we need to join the dots and see what happens. So again, we have an exponential function. It's going to probably look something like this. This is our y asymptote, or sorry, our horizontal asymptote. And this is a sketch of our function. Y equals 2 times 4 raised to the power x minus 1. A little rough, but it's a general idea. Good. So that brings us to the end of our session. So if you have any questions, give us a shout at info@raisebymarks.com or give us a call, and thank you for watching.